hello, this is Unit 4, Lesson 5. We'll be solving by division. First, we're going to look at long division to evaluate a polynomial. And then we're going to look at synthetic division, which we'll use to help solve. Okay? So first, let's look at long division. All right, this can be tedious, but once you understand the steps, so it's really not too bad. So let's look at this example. So what we're saying is 3x to the fourth minus 4x cubed plus 12x squared plus 5 divided by x squared plus 1. So we want to write it. We have our divisor here. All right. We have all of our other function, our other part of the function in here. Okay, with a radical, radicand. Okay, so you want to find what the result is here. You're dividing this in the same way you divide in long division. Something like let's see if 120 goes into 15,000. We're doing the same idea. Okay, we'll see it divides in evenly. You might get a remainder, you might not, and we'll show you how to write that. All right. The first step I would do, what you got to make sure is inside the radical is that you have every degree accounted for. Meaning I've got fourth degree here, I've got third degree here, and so on. But I'm missing the first degree. So I'm going to have a placeholder for that. And then my constant term. Okay. The next thing is that I'm going to make columns. Because you want to keep, when you do this, you want to keep all of the like terms in the same column. Okay. Now, x squared plus 1. The first step is I look at the first term here. I want to see how many times what I have to multiply to x squared to get into 3x to the fourth. All right. So it's kind of backwards. You're really dividing 3x to the fourth by x squared to see what our first term is in the quotient, okay, or on top of the radical. All right. So 3x to the fourth divided by x squared is 3x squared. Okay. So I put that in the x squared column. All right. Now I take 3x squared and multiply it back into by the divisor. So I get 3x to the fourth here. That's supposed to happen. That's supposed to be the same. If it's not, you did something wrong. And then I take 3x squared and multiply it times 1. I get 3x squared, so I put that in the x squared column. 3x squared. Yes, I skip a term, but it's just like having a 0 there. Now the tricky part is I'm subtracting this. All right. So if I had a positive here, I'm actually subtracting it from 12x squared. All right, so that's 9x squared here. 0x. You'll need to bring down your 5 as well. Okay. And now start over. Go back to your x squared. What you have to multiply it by to get to 9x squared, you should get 9. So that's going to go here. 9 times x squared is 9x squared. 9 times 1 is 9. Again, you're subtracting this. So 5 minus 9 is negative 4. So what we have for our result of this evaluation is 3x squared plus 9 with a remainder of 4 over x squared plus 1. Okay, so this means that x squared plus 1 did not go in evenly to the radicand because there is a remainder. It means that x squared plus 1 is not a factor. Okay. All right, so try number 1. All right, here are your steps. So inside the radical, you don't need any placeholders because all your degrees are accounted for. It goes from 3rd degree, 2nd degree, 1st degree, constant. Okay? You get 2x squared plus 5x plus 2. There's no remainder. Okay? So that means that x minus 4 is a factor of this function. Okay? X minus 4 is a factor. Okay, so that is long division. You need to use long division if you have a binomial that's not linear, okay, or any term that's not linear. If it's x squared or greater, okay, if your divisor is x squared or greater, you have to use long division. Okay. All right, so let's look at synthetic division. So synthetic division is a lot of the same. It's the same idea, okay? You're really going to just be using, you are just using the coefficients, okay? So the key for this is the divisor has to be linear. It means you can't have an x squared. It's got to be x plus or minus some number, okay? If it's x squared, you cannot use synthetic, x squared or greater, you cannot use synthetic division. Okay, so you're just using the coefficients of each term. You still need to have placeholders. Okay? But what you use for the divisor, if this is we're seeing if this is a factor or not, you need to use the 0 of that factor. Okay? So instead of using x minus 5 as the divisor, you use 5. And you have a different setup here. Okay, you write the coefficient of the first term, coefficient of the next term, and so on. Now, we don't have an x squared term, so I have a 0. And then I have 8 for my linear term, negative 40 for my constant. Okay, I'm just going to write these again up here. So this is my quartic term. This is my cubic term. This is my squared term, which was a placeholder, linear, and constant. Okay, that's how you set it up. Okay. First step is, whatever the leading coefficient always comes down, no matter what it is. In this case, it's 1. It's not always going to be 1. If the leading coefficient was 3, you'd bring down a 3. If the leading coefficient's 1, I'd bring down the 1. Okay? So, now I take this 1 that I brought down and multiply it by this 5. And then I put it here. Okay? This is where it's the opposite. Since we changed this sign, this 5 here, instead of x minus 5, all right? Instead of subtracting right here, we just add. I say just combine them. So negative 5 and 5 is 0. Okay, then I repeat the steps from there. You always multiply the bottom row times the divisor, put it in the middle row. All right, so 0 times 5 is 0. 0 and 0 is 0. Next number. All right, 0 times 5 is 0. 8 minus 0 is 8. 8 times 5 is 40. And I get 0 for my last term here. All right, so you're thinking, great. What does this mean? We're actually done dividing, so it's a lot fewer steps than long division. So people are saying, well, why can't we just use this in the first place? Again, it has to be a linear term. Okay, so some things to point out. This last term is your remainder. You won't always get 0. But if you get 0, that means that 5, the original divisor, is a root or 0 of this function. If the remainder is 0, that means the divisor is a root or 0 of the function. Okay. The last term here, again, is a remainder. Now, you need to rewrite these coefficients at the bottom as the result, okay? So this also means x minus 5 is a factor. X minus 5 is a factor, 5 is a root. So we need to rewrite what we have left. So we divided by 1 degree. So what's left is the next degree down from x to the 4th. So this is now, what's left is x cubed. These are all placeholders. This was my squared term, this was my linear term, and this is my constant. So the only thing that's left is the constant. So what's left is x cubed plus 8. That is your result. So if we say evaluate, x cubed plus 8, no remainder. Okay? Go ahead and try number 2. Right, so we're evaluating 2x cubed plus 7x squared plus 10x plus 8 divided by x plus 2. All right, so negative 2 is your divisor. You have your coefficients. You don't need a placeholder. Okay, so the result you get is there's no remainder. Again, that will not always happen. That's just how these worked out. Okay, there's not a remainder. Sometimes you will, sometimes you won't. Okay, we'll explain more about what that means next class. All right, for lesson 6. Okay. All right, so you get 2x squared plus 3x plus 4 is the result. That's the result of evaluating this division. Okay? So now let's look at using synthetic division to actually solve a problem. Okay, so top problem on the back. So we have this quartic function. We don't know how to factor this. So what you need to do is, we'll tell you if something is a factor or a 0. You can reduce it using synthetic division. Then you'll factor, and then you'll solve. You'll find the zeros. Okay? How many zeros are you going to end up with total? You should have 4. 4 total zeros or roots. They could be real, they could be imaginary. Okay? So let's do the first step, use synthetic division. So if x plus 2 is a factor, that means I'm going to use negative 2 as my divisor. Do I need any placeholders? I go from 4 to 3 to 2 to linear to constant. I don't need any placeholders, so I write what I see. 3, positive 11, positive 22, positive 44, and positive 40. Bring down the leading coefficient. Okay. Now, I'm telling you that x plus 2 is a factor. So that means you should get 0 here. Okay, if you don't, you did something wrong. All right, if x plus 2 is a factor, I should get 0 for the remainder. All right, so let's go through our process. 3 times negative 2 is negative 6. 11 minus 6 is 5. 5 times negative 2 is negative 10. I get 12. 12 times negative 2 is negative 24, which is 20. 20 times negative 2 is negative 40. 40 minus 40 is 0. So we did it right. I got 0 as my remainder. I have 3, 5, 12, and 20. Okay, so again, I divided a 4th power by a 4th degree by 1 degree. So this next level is going down a degree, meaning this should be written as 3x squared plus 5. Oh, that's wrong. Should be 3x cubed. Sorry about that. 3x cubed plus 5x squared plus 12x plus 20. Now you need to factor this to find the remaining zeros. So we proved essentially that negative 2 is a 0 by getting a remainder of 0. So set this equal to 0, now I'm going to factor. Okay, we learned how to do this by grouping last class, so we're going to go ahead and group this. Factor out greatest common factors, x squared. What's left is 3x plus 5. And then over here, I'm factoring out a 3. Dividing out by 3, dividing out by 4. Take out a 4. I get 3x plus 5, which is what we should get. So my factors are x squared plus 4 and 3x plus 5. Now we need to solve. So x squared plus 4, x squared equals negative 4, x equals plus or minus the square root of negative 4. Negative inside a radical, we should get an imaginary term that happens to be 2i. So those are our two solutions. What are my other ones? 3x plus 5 equals 0. 3x equals negative 5. X equals negative 5 over 3. So I have 2 zeros here, 1 0 here. All right, so that's 3. Remember, we're supposed to have 4. You're like, well, where's the fourth one? Well, we were given the fourth one, negative 2. You need to write that. So we say x equals negative 2. Those are your 4 zeros. Again, real or imaginary. There's 2 real and 2 imaginary. 4 total. Okay? So go ahead and try number 3. All right? So you do your synthetic division. You should not get a remainder. The remainder should be 0. If you didn't, double check. All right? You get x squared plus 2x squared minus 9x minus 18. We factor by grouping. Factors from that are x squared minus 9 and x plus 2. So I have x equals plus or minus 3, x equals negative 2, and x equals negative 1. 4 total roots, 4th degree. Okay? Make a note of any questions. Bring those to class, and we'll see you then.